Hey there, my wonderful chemistry students. Organic video lecture number 3. Today we delve into the alkenes and alkynes, piggybacking off of lecture 2. And Mr. Milks, please make this video shorter than the last one. It was brutal. Let's hope we can do that. Today, basically, we're just going to deal with double bonds and triple bonds and some rules associated with those. Okay, so we've done um, the first part of the homologous series. Now we're going to get into single or double bonds and triple bonds. So here we go. Now, remember, aliphatics just means it's a chain, it's a line. Unsaturated means it doesn't have as many carbons as it should. So hydrocarbon, specifically with this double bond, is an alkene. I don't know how we remember that. Maybe there's two E's in it. But to be honest with you, we don't really need to, because if we go back to table Q, I look up the name alkene, and if I look over, there's a double bond in the C. So there's how I know. All right, propene. Prop means 3 carbons. 1, 2, 3 carbons. And N equals 3. And my equation changed now. It is CnH2n. So if I plug my 3 in, I have 6 hydrogens. So I'm going to do it out like this, right? 1, 2, 3. Double bond and a single bond because it's an ene. And I use my formula to say that I have 6 carbons or 6 hydrogens. 1, 2, whoops, I did that backwards. 2, 3, 4, 5. Notice there's 1, 2, 3, 4, 5 bonds around 4 bonds around this carbon. There's already 3 around this one, so I only put in one more H. 1, 2, 3, 4, 5, 6. And it looks just like the one that was already there. Mr. Mouse, that's why these videos take so long. You keep doing the videos that are, or the structures that are already there. No, you only need to include a number for the multiple bond if it's not at the first location. So that would be these examples here. So remember, I told you the naming rules. If I start 1, 2, 3, 4, 5, the double bond would be at this 3rd carbon. So that's at carbon 3. Let me name it the other way. 1, 2, 3. Now the double bond is at the 2nd carbon, so I want to start at the right and name over 1, 2, 3, 4, 5, so that the double bond is at the smallest numbered carbon. 5 carbons is pent. I'm going to raise this board up a little bit so I don't have to bend over. A double bond is an ene, and it's at 1, 2, so it's 2 pentene. Okay, I'm going to tell you where that double bond is. Again, I don't even bother start counting at this carbon here because this carbon's 1 and there's a double bond. So 1, 2, 3, 4, 5. Help, I'm dying. So I have 5, which is pent. It's an ene because I have a double bond in there, and now I need to tell you where those double bonds are so you can draw it properly on 1 and 3. 1, right? 1, 3, and there's 2 double bonds, so it's di. Oh, it's pentadiene. We put the di in front of what is double. So let me just redo that. 1, 3, pentadiene. Di mean 2 double bonds. I don't want to do a dipenta because then it makes it like I have 2 5-carbon chains. Okay, branched alkanes, the branch prefix comes first in the name of Ken and then the parent, and then the parent is going to, of course, end in the ene to show me that there's a double bond. Okay, so again, I'm going to go 1, 2, 3, 4, because otherwise I go 1, 2, 3, 4. It's really the same thing. 4 carbons. Looking at my reference table is bute. I have 1 double bond, so it's not a diene, so I can call it pent or butene. I need to tell me that it's at the 1st carbon. At the 1st carbon, I don't need to tell you. I can assume that. I only put the 1st carbon here to show you that it's at 1 and 3 because there's at both. If it was just at the 1, I could just leave it as pentene. Okay. So I have this taken care of. I need to take care of this now and this. Each side chain is a single carbon, so it's a methyl and a methyl. So it's a 2,3 dimethyl. 2,3 dimethyl. Butene. Now the beautiful thing about this naming things, I can go forwards or backwards. I can go from the structural formula to the name, which I just did, and then I can go backwards. I can give you the name and you give me the structural formula, but because of these rules, it makes that so I can get it right every time. Okay. Now, triple bonds is the alkynes. I pronounce it alkyne. That's how I pronounce it. I'm not sure how Monaco does it. Basically, there is this triple bond. Okay. It's going to have a new equation. Now it's 2n minus 2 because I'm going to lose 2 more hydrogens to that bond. I'm going to end it in -ine. Okay. The n tells me where the triple bond is, of course. So in this particular case, I'm going to start 1, 2, 3. I have a triple bond. 3 carbons is a prop. Triple bond is an -ine. It's on the first carbon, so I don't have to tell you 1 propyne. Okay. 1, 2, 3, 4. 4 carbons is a but. I have an -ine triple bond. I need to tell you where, and that's 2-butyne. So 2 things I want to elaborate about this because this is a great teachable moment. If I were to name it the other way, right? If I were to start on this side and say 1, 2, 3, 4, I would still get the triple bond at 2 because this is the same. It's symmetrical on both sides. It doesn't matter which way I write it. I can flip it all around. I'm going to draw it the same way by saying 2-butyne. So I'll never get a 3-butyne because a 3-butyne, if that triple bond was, let's say, here, and this was just the single bond, right? 1, 2, 3-butyne is really, flip it around, call this 1, 2, 3, 4. It's really 1-butyne. And notice 1-butyne and 2-butyne are 2 different things. And one we would actually just call butyne. So I just wanted to throw some of that little extra stuff in there to show you why this kind of works specifically. Okay. I only need to include the number of the multiple bond location if there is more than one possible location. So that's why with the 2 I have to put it in there because it could be on the 1. It would never be on the 3, but it could be on the 1 or the 2. So I have to write that it's a 2 because it could be either place. Okay. Straight chain alkanes. State the lowest carbon number where the triple bond is, located on the suffix. Again, if I start on this side, it's 1, 2, 3. If I start on this side, it's 1, 2, 3. So in this particular example, it doesn't really matter. It's going to be on the 3 either way. I have 1, 2, 3, 4, 5, 6 carbons. 6 carbons. I look on my reference table. 6 is a hex. 9 to show me that there's a triple bond, and I have to say it's 3-hexyne because it's on the 3rd carbon. If it was here, it'd be 2-hexyne. If it was here, it would just be hexyne. Okay, I'm just throwing some little extras at you. I want you to go ahead and name me example 2. This is a you do. Number 3, I'm going to do out. Pentyne. Pent is 5. 1, 2, 3, 4, 5. It tells me on the 2nd carbon I have a triple bond. 1, 2, 3. Fill in my bonds between the 2nd carbon now has 4 bonds. The 3rd carbon now has 4 bonds. 4th carbon has 2 bonds, and I'll just fill them in with H's so that they all each have 4. Notice the rules. The 2nd carbon has 4. 3rd carbon has 4 as is. 4th carbon needs 1, 2. 5th carbon needs 3. Okay, and there we go. I was able to do it forwards and backwards. All right, now we have some more examples. Branched alkynes. It's the same thing, guys. I just know now that I have pent is 5 carbons. I have an ine at the 3rd carbon, and on the 2nd carbon, I have a methyl. Okay, so I just talked you right through it. Let me draw it out quick. 1, 2, 3, 4, 5 carbons. On the 3rd carbon, I have an ine, 2, 3. On the 2nd carbon, I have a methyl, which is a CH3. Fill in the rest of my bonds so that all my carbons have 4. 1, 2, 3, 4. 1, 2, 3, 4. Has 4, has 4. 1, 2, 3, 4. 2-methylpentine. This thing we got to name it. So let's do the chain. I'm going to say 1, 2, 3, 4, 5, 6, 7, 8. 8 is an oct. It's an ine because there's a triple bond. The triple bond is on the 3rd carbon. So it's a 3-octine. On the 2nd carbon, I have an ethyl. So I have a 2-ethyl. And let's see, on the 6th carbon, I have a 1-carbon chain, which is a methyl. So it's 2-ethyl, 6-methyl, 3-octine. Beautiful. All right, 3 and 4, I'm going to leave as you-dos. They're going to follow example 1 on this page. Okay, and 4 is a you-do. And 5 I will do. Hept. Hept is a 7 carbons. 1, 2, 3, 4, 5, 6, 7. It says on the 5th carbon I have an ine. 1, 2, 3, 4, 5. I have my triple bond. It says I have 2,3-dimethyl. So on carbon number 2, I have a methyl, which is a CH3. And on carbon number 3, I have a methyl. And I'm just going to let you know instinctually, I never draw them both on the top. I draw one on the top, one on the bottom, or one on the bottom and one on the top. I never draw them both up there. And it's just instinct. We'll get into why on that maybe later. See, bond up my carbons. Now make sure each carbon has 4 bonds. This one needs 3. This carbon needs 1. This carbon needs 1. This carbon needs 2. This carbon has 4. This carbon has 4. Last carbon needs 3. And we just drew it out based on its name. And so I know it looks really complicated. I know I kind of went fast. Maybe you need to go back and just watch it once or twice more to really get the hang of this. And of course, a little bit of practice is going to go a long way. So now I have alkenes and alkynes under our belt. We have our double bonds. Let me put 2 lines and our triple bonds under our belt, types of straight hydrocarbons. I can add on branches, and it still works the same way as the anes. Now, I can get all the way through page 6 of my practice packet, and now you're going to have a quiz. So make sure, like before in the previous units, you do your prep, then you do your quiz, and then if you don't pass your quiz, you say, Mr. Mills, I passed my quiz. But guess what? You're going to do your prep, and you're going to study hard before you take a quiz, and you're going to pass it, and everything's going to be good. So until tomorrow, see you.